Hello and welcome back to WySLICE. We've had a look at Conway's Game of Life in our previous activities. In particular, we had a look at this website that allows us to very nicely play around with this. So you can use your mouse to create live cells, and then you just start the simulation and the steps through it, and you can very easily see what happens with your initial pattern. We're now going to take a step back and have a look at this in an analog way, so that hopefully we can improve our understanding of how this works, which might then help us with what you've had a look at before, where you try to identify patterns that essentially result in interesting simulations. So nothing that just immediately disappears or reaches a stable state or kind of flip-flops between two not very interesting things. Okay, and for this, I want you to take a piece of paper and draw a simple pattern on it. I've done this here, so I'm going to start with just these 3 cells, and I want to find out what happens in the next iteration of the simulation. And for this, let me bring up the rules of the game again. You can find these on the website. Here they are. So for spaces that are not populated, so for empty grid cells, for spaces that are populated, if the cell has 1 or no neighbors, then it dies. If it has 4 or more neighbors, it also dies. If it has 2 or 3 neighbors, it will survive. And for unpopulated cells, so for the empty grid cells, a cell becomes populated if it has exactly 3 neighbors. Okay, so what does this mean in my particular case here for these 3 cells that are next to each other? Well, let me see. So the middle cell has 2 neighbors, so it survives. The 2 outer cells have 1 neighbor each, so they die. Okay, but then we also have the cells to the top, the empty cell, and the empty cell to the bottom, which have exactly 3 neighbors each. So my next iteration would look something like this here. So I've kind of flipped around the pattern. And now let me apply the rules again. Okay, what's going to happen here? Well, we're actually going to flip back. So the top and the bottom cell are again going to die because they have only 1 neighbor. Middle cell is going to survive, and the left and right cells are going to be populated. So they're going from unpopulated to populated because right now they have exactly 3 neighbors. So we kind of end up with the original pattern again. Looks like this here. And then, okay, I guess I've chosen a relatively easy to simulate pattern here because this will just flip and flop between those 2. We can check this. Let me go back to the website here. And here I've created this pattern by, instead of clicking the start, clicking the next button. So this steps 1 iteration. Okay, seems that I got that right. And okay, I got that right too. And as we can see, this kind of, keeps going. You can also just press the start button here and then see that this flips and flops back and forth between these 2 particular configurations. But what I want you to start with is not the website, but really just draw a pattern on a piece of paper and then step through it manually, applying the rules that you can bring up again on the website to remind yourselves. Obviously, you should probably do this with a relatively small pattern because otherwise this can become really quite tedious. And then, of course, you can go to the website and check your work afterwards to see if you can successfully simulate yourself the rules of the Game of Life. And hopefully, one of the things that you will take away from this is to get a little bit of a better understanding on how these different patterns, how the different configurations interact between iterations. So where are we creating new live cells? Where are cells dying out, and so on and so forth? Exactly what we had a look at in the previous activity. So trying to identify how we can get interesting patterns. But again, now I want you to be the computer. So we're going analog here, and I want you to step through these iterations yourselves, at least for a bit. Obviously not quite to the same extent to which you can do this on the website, because the computers are there for a reason, right, to do exactly these kinds of tedious things. But still, there's some benefit to doing this manually. In particular, in a case like this, where we really don't have a very good understanding of, well, how does this work, right? I mean, simple rules, but as we have seen, by running these on even relatively simple patterns, we can get really quite complex behavior that is difficult to predict, and maybe stepping through this manually gives you a better idea of how all of this fits together and where some of the interesting behavior that you may have seen comes from. So have a go at this and have a little bit of fun with this as well.